All right, this is our last ellipse example. In this one, I'm given 3 points, 2 vertices and a focus, and then I'm asked to find the other 7 key points and the equation and the graph of the ellipse. So a lot of things to find here. So first of all, what I would do is I would plot these. Again, I think about things visually, personally. You could do this algebraically as well, but I like to plot these things, get a feel for what's going on with this ellipse. So I see the 2 vertices are at 2, 3, and 2, 10. So I go over to 2 and up to 3. There's focus 1, or vertex 1, sorry. Vertex 1. And then over to 2 up to 10. And that's going to be vertex 2. Right? So there's my 2 vertices. Then my focus is at 2, 9. All right, well, what does that tell me? That tells me that the major axis is vertical, right? As soon as the vertices are lining up vertically here. So that's probably better. So yeah, this is major axis is vertical. It means the bigger number is going to be under the y squared term. I can also find some information here. First of all, I know that the center is halfway between the 2 vertices. So if I think about these vertices being there, it's a fixed value of 2 in the x direction. So I know that the center will be at 2 in the x direction. I just have to find the y value now. The y value would be the average of the 2 y values in the vertices, right? It's halfway between them. So if I average them, that'd be 3 plus 10 over 2, right? You add them together and divide by 2, that's an average. That gives me 13 over 2, which is 6.5, okay? I'm going to go ahead and put these in as decimals. I don't always do decimals, but because I'm plotting this, I like the decimal form. So I want 6.5. Let's see, 3, 4, 5, 6.5. We'll bring that over. So there's our center. Okay, that's big C, even though it was kind of little up there. And of course, I'll put that coordinate in. 2, 6.5. All right. Now the other focus. Well, let's first find our distance now from the center to the focus, and then I can just subtract it and find it the other way. What's interesting is it's going to be symmetrical with the vertex too. So I can do this 2 different ways, and maybe I'll do it the simpler way. I know that the vertex and the focus here are only 1 unit apart, right? One's at 9 and one's at 10, and so that's got to be the same for the other vertex. There's symmetry to these ellipses. And so if this vertex is at 2, 3, then I move 1 unit up, that should be at 2, 4. All right, so the other vertex then, F1, must be at 2, 4. And if I just check that quickly, the difference from 6.5, the center, to 9, the first focus, is 2.5. The distance from 4 to 6.5 is also 2.5. Okay, so that is consistent. That does tell me then, oh, and I can plot that too. I can plot that right there. That is focus 2. No, focus 1. I just labeled those incorrectly, didn't I? Focus 1. Focus 2 is up here. There we go. I had those foci labeled wrong. That's okay. We'll get it right. Now it's making sense. Okay, so all those things are along the major axis. I can also find little a and little c off of those, right? So little a is the distance from our center to the vertex, center to vertex, and it doesn't matter which vertex, I just subtract those values. So I could do 6.5 minus 3, that would be 3.5. That's our value for little a. Value for little c is going to be, that would be the focus to the vertex, or to the center, focus to center. So that would be 6.5 minus 4, which is 2.5. Okay, so I've got my a and c values. Well, why is that important? That's what helps me find b, all right? We know that b squared equals a squared minus c squared, and so I can substitute my a and c values into this formula to find b, or at least to find b squared too. So b squared is going to be, well, 3.5 squared minus 2.5 squared. 3.5 squared, that's 7 halves squared, is 49 fourths, which is 12.25. So b squared is 12.25 minus 2.5 squared is 5 halves, that's 25 fourths, which is 6.25. Now the difference between those is, what, 6? Yes. That looks like 6, all right. So that means our b squared value is 6. That's kind of nice. And that means that b itself is going to equal the square root of 6, which is approximately, I don't know this one offhand, about 2.45. Okay, so approximately 2.45 is our b value. So that means from the center, going left and going right, I need to subtract and I need to add 2.45 approximately to that center value. So the two endpoints on the minor axis, they're going to be at a fixed height of 6.5. And then I need to take this value of 2, which is the major axis, and I need to subtract 2.45 and add 2.45. So that would put me at 4.45, comma 6.5. Right? So that's the 2, add a 2.45, keep it at the 6.4 or 6.5 high. And then if I subtract the 2.45, I'm going to get 1, 2, and that's going to be negative 0.45. Well, I can't keep that vertical, can I? Here we go. Let's redo that. All right, somewhere in there. So that is at negative 0.45, comma 6.5. I need more space. Negative 0.45, comma 6.5. That's the other end of the minor axis. Okay. And so I found all 7 points, right? 1, 2, 3, 4, 5, 6, 7 total. I was given 3, I found 4. Now I can plot the graph through those points, right? So I can connect the ends of the axes. All right, that's not too bad. All right. And then I need my equation. Now the equation of this ellipse, remember, is going to be, now this is, the major axis is vertical. So the a goes under the y and the b goes under the x. So it's going to be of the form x minus h squared over b squared. Do I need more space? Yes, I do. I'm going to run out right there. Let's put it down here. X minus h squared over b squared plus y minus k squared over a squared is equal to 1. And when I fill in my h, k, which are the center coordinates, and the b and a, which I found here, b squared is 6, a squared, we said was 12.25. So we can plug all that stuff in. I get x minus 2 over 6 plus y minus 6.5 all over, a squared, what did we say? A squared was 12.25. And both of those are squared, there we go, is equal to 1. That should be it. Now, if I wanted to keep this in fraction form and not use the decimals, that could be useful as well. You may see that 12.25 is 49/4, but if you're dividing by that, it's like multiplying by 4/49, if that makes sense. Hopefully that makes sense. This is really, right, 49/4, but you're dividing by it. It's on the bottom, so you flip it. I could really write this in fraction form as x minus 2 squared over 6 plus, now if I multiply by 4/49, that would be 4 on top and a 49 on the bottom. And the 6.5 is really 13/2, so it would be 13 over 2 squared equals 1. So that would be another way to write that in fraction form. Again, dividing by 12.25 is exactly the same as multiplying by 4 and dividing by 49. Okay, so that combination is the same.